right? And I will share my screen. So make sure to say in the chat if you can see the screen or not. If you can see the screen or not. Okay.
Yeah.
So can everybody see the screen? Yes, okay. Very good. So let's start. This is lesson 1.1, which is just a very brief introduction. Today we will not be doing anything hard. It's just a very brief introduction. So let me actually see how old is everybody here, because that may change some lesson plans. I want to know what grade are you in. So can everybody put in the chat, what grade are you in? 6. Okay, so 6 is I think a good age to start learning algebra. Usually in school you learn algebra in 8th grade. So you'll be learning algebra like 1 or 2 years before your classmates. So that's very good. Okay. So that's very good. If everybody is around 6th grade or 7th grade, this should proceed very smoothly. And let's just start then. So this is lesson 1.1, introduction. Today we will be going over, class details, what I'm going to talk about in this class, a little bit about homework. I think usually the classes are around 1 hour, but this one is going to be a little bit shorter because it's just the first lesson. Our actual first lesson of material will start on 21. This is January 21. Right, the next Sunday. This is a preview of what will happen. So, and then I'll go over class details and pre-assessment problems that a lot of you, the difficult pre-assessment problems that you may have missed. So yeah, I'll make sure to go over those, and then we'll just finish off with the basic operations. Very easy. Basic operations, order of operations. Okay. So, first, as a self-introduction, my name is Tianle Liang. I'm a high school sophomore. I take pre-calculus honors in AP statistics in school, but I've learned calculus in extracurricular classes. It's not really that hard. For math competitions, I've gone to the major ones like math counts and AMC. Once you get older, you can probably participate in those too. So that's all for me. And now, before I go into the actual short introduction of what you will be learning in this class, let me just pull up a document on my computer. It's basically the list of topics that we will be going over, in case you did not catch those. So let me just pull that up real quick. Give me like a second. Okay. So, let me read the curriculum first. This unit 1 is going to be very short. It's on the introduction and basic operations. So this is for anybody that is not too familiar, the younger ones, right? Anybody that is not too familiar with operations yet. Of course, I don't really know what you learn in 6th grade. I kind of forgot because 6th grade was a long time ago. But I think you do learn some basic math, right? You learn some basic math. You haven't started on any algebra yet, right? So that's what you're going to learn. So introduction, basic operations, basically review of the basic math material that we will be relying heavily on this course. Unit 2 would be solving equations. All right. Basically, the premise of algebra is to solve equations with variables and such. Unit 3 is on word and applied problems. You've probably heard of word problems before. Maybe you've done word problems before. We're going to apply algebra in these word problems. So those are the first 3 units. It's going to be very basic. The first 3 units, just the very basics of algebra. Unit number 4, we are going to be going into some more detailed stuff on functions and graphing, right? So functions are very important. Later in advanced algebra and calculus, you'll be basically working with functions a lot, right? So this will be your introduction on functions. Unit 5 is linear equations. This is exactly what we're here for. When people think of algebra, you think of linear equations, right? So unit 6 is going to be solving systems, which is just a system would be a bunch of linear equations. I'll get more into that when we actually reach unit 6. Unit 7 will be on exponents and polynomials. Okay, so I don't know if you heard the term polynomials or exponents, but once we get to unit 7, you'll be more exposed to algebra, so it will be it'll flow better, right? So unit 8 will be factoring expressions. We're getting into factoring, which is very, very useful skill, right? Unit 9, we are going to be going over rational expressions and equations. And then unit 10, we are going to be going over radicals. Unit 11, we are going over quadratic expressions and equations. The last unit, unit 11, will probably be the hardest unit of all. We are learning quadratic equations, right? If anybody has heard the quadratic equation, I don't know if anybody's heard that, but we will be working with that a lot. I will prove any theorems, though there aren't any in Algebra 1. I will try to prove any formulas, but again, I don't think there's a lot of formulas in Algebra 1 that you need to memorize. First of all, of course, you do need to know Pythagorean theorem. So if you do not know Pythagorean theorem, just say so. It's pretty easy learning, right? Pythagorean theorem. I think since most of you are around 6th grade, 7th grade, you should know what the Pythagorean theorem is. Some of our formulas, when we're learning about linear equations and functions, we will be working with these with the Pythagorean theorem a lot. And yeah, that is all for the curriculum. And under the curriculum on the document, I think some of you have access to it in the WeChat group or whatever. Basically, each class, please prepare a notebook, right? Please prepare a notebook. That notebook is going to be used for, writing notes. Please write notes by hand. Do not do it digitally. Studies have shown that when you write notes by hand, it helps with the memory abilities. So I'd very much recommend writing your notes by hand instead of digitally. And also, you must prepare a notebook to do the example problems that we will encounter. We will do some example problems, right? And then there's going to be homework after every class. So you can so I don't know if how many of you have joined the Google Classroom. Let me check real quick. So I think 11 students have joined the Google Classroom, and you should check if you're in the Google Classroom or not. If you're not, please join. I think the code is MZW25AG. It's in the WeChat group, so make sure you check that to join the Google Classroom. After every class, there will be homework. Usually for shorter problems, it's going to be 5 problems. 5 problems after the class. It's very short. I don't want to take too much of your time, right? Just 5 problems. Even a little bit of practice every week is going to have a great impact in the long run. So make sure you do your homework. As we go along, when we get harder questions, the homework will probably be shortened to like around 3 questions because I'll give like harder, longer questions. But don't worry, this is not exactly like math competition class, so it's not going to be that hard. Just very, very good practice of what we learn in class. So that should be effective in memorizing the material and also using it later on. So I know the people in around 6th or 7th grade, you are learning algebra 1 or 2 years before your peers, so that is very good. You are able to be exposed to more high-level math than people around you at a younger age, so that's should be very good to your academic endeavors or whatever. So make sure you get the most from this class. Now I'm done talking about the curriculum. We can actually go over what exactly is algebra. So this should be brief. Algebra is one branch of mathematics, of course. So before 6th grade, I think you all, learned about math multiplication, division. You learned about addition, subtraction, long division, multiplying all of those things, right? Now that we've got a solid understanding of those basic operations, which we will review in this unit, we are now going to move on to more advanced mathematics, where we are not only working with numbers, we are working with variables. So algebra is the fundamental basics of number manipulation. It is the basis. It is used in many subjects, higher subjects like analytic geometry, right? In geometry, you're going to use algebra a lot. I mean, algebra is basically in every branch of mathematics that you're going to see. You're going to use it in calculus. You're going to any other STEM subjects like chemistry and physics. So no matter if you're going into STEM, if you want to go into STEM, science, technology, engineering, or math, if you want to go into a STEM field, you need to take algebra and you need to do well in it, because you're going to use it no matter what. If you do physics, if you become a chemist, if you can become like you go into biology, right? You're all going to use algebra sometime or later, right? So make sure you pay attention in this class. It's going to be quite important to the future when you are learning math. And basically, it is the manipulation of variables and numbers. So previously, you've just used numbers, right? 2 plus 2 is equal to 4, right? That's just numbers. 2 is a number, 4 is a number. However, now we are manipulating variables. Variables can be defined as placeholders for numbers. For example, x, y, theta, for example, alpha, beta. All of these things can be defined as variables. Okay, they can be defined as variables. Anything can be a variable, actually. It's just a placeholder, right? So, for example, let's say that x plus 4. You want to find x plus 4, and you know that x is equal to 3. Well, x plus 4 is equal to 3 plus 4, which is equal to 7. You see how x is a placeholder. We'll talk more about the actual variables later. So that's a brief introduction of algebra. Before I go on to actual classroom details and expectations, do I have any questions about curriculum or any questions about other things? Class code, right? Okay, so let me type the class code in the chat. I have the Google Classroom pulled up right now. It's going to be all lowercase MZW 25AG, I think. Right, so all of you can go onto googleclassroom.com, and I think it has a join class option. You need to click on that and submit the code. Actually, yeah. Sorry, that was a direct message. I don't know. Let me send this to everyone. So if you can see it in the chat. Also, one thing that I didn't mention here is that this is a very interactive class, all right? You cannot learn math just by listening to a lecture. You need to actually do things, right? So when I talk about these problems and I ask for volunteers, please volunteer to solve these problems, right? If you know them, even if you do not know them, it is good to try and solve them, right? So do not be shy or scared. I will help you through any problems that you did not understand. And don't hesitate to ask questions. Of course, asking questions is very important. So now let's go on to classroom expectations. So hopefully everybody got the code in the chat. And if you have not If you have not entered the classroom yet, please do so. So I think how many people are here? 14 people. Okay, 14 people. Right. So, and there are 11 people. 13 now. There are 13 people in the classroom, so one more person has to join the classroom. So whoever those two students that just joined now, thank you very much. Okay. So hopefully everybody will be in the Google Classroom by the end of this lecture, because we're working out the logistics here. All the classroom updates, all of the assignments, all of any updates, any postponements, any changes in schedule will be in the announcement part. So everybody can pull up Google Classroom on their laptop or whatever. You can see how you can click through. You can go to classroom. You can go to grades. I won't actually grade homework like in points. You will get, like, for example, a completion grade, and then I'll talk about the homework later on, and then you can check your homework, and I'll talk more about homework policy later. So that's it. I don't really have much updates in the classroom yet. All I did was a reminder for today, and I should already have posted the homework for this class actually. So I'll usually post the homework before class or after class, and it will be corresponding with the lesson. And after the lesson, make sure you check, because if you did not understand a part, or if you was not able to come, then you can check out the recording link. The recording link will be posted 1 to 3 days later when I get it processed. I think should email me with a recording link, and I will post it in the Google Classroom, and then you can check the recording link. I doubt many people are going to check it, but I just have it there as a good resource. If you truly do not understand anything, then you can go and review. Otherwise, if you go and review the recording and you still do not understand anything, well, that's a shame. You just have to email me, and I will respond within 24 hours. Okay, so email me if you do not understand anything. Once you are in the Google Classroom, you can access everybody's emails, right? When I go to the student section, I can see all of your names, and I know all of your emails when you sign up, and you should be able to contact my email too, right? So you can email me for any questions about homework, any questions about the material we covered in class. So all of those questions, or maybe you have like a separate math question that doesn't even relate to class. I will try my best to resolve your issues and problems in the email. So you can see the emails. Okay, that's great. Let me just actually just type my email in the chat here. Yes, this is my email, I think. Right. So it should be in the chat. So everybody save my email, and you should be able to contact me. If not, you can literally always post something in the classroom. So even if you can't email, you can post something in the classroom, and I will be able to see it. It sends me an email every time somebody posts something. So if you truly cannot access the email, then you can post something in the Google Classroom. All right, so that's all for the classroom and how to access, how to navigate it. So for those first time using Google Classroom, hopefully you understood how to navigate it. I mean, all you really have to do is to look for updates and look at the homework. That's all you need to do, right? So now let's go on to some classroom details. So first it was join Google Classroom. Yes, we did that already. So hopefully, let me see. 13 people are in the classroom. One more person needs to join, but that's fine. So how will each lesson be? So first, in each lesson, we will start with homework review. So I'm not just going to assign you homework and not tell you the answers, right? So every lesson, I'm going to start with a brief homework review. You can ask questions during that time, right? If you ask questions about the homework, what you don't understand, right? That's very good. And I'll introduce new learning material. So we're going to start with, half review. We're going to review, and then we're going to introduce new material. And then we're going to, the first half is going to review, second half is going to be new material, and then we're going to repeat that process. I've taught this course like one time a few years ago. I've taught basic algebra, which is algebra 1 and algebra 2. So, and last time this format worked quite successfully. So we will be doing that also this time. And lastly, of course, you cannot learn math correctly if you do not do any practice problems. So I'm going to have a lot of practice problems in the class and also in the homework. So make sure, of course, you do the homework. Now on the homework, of course, yes, review the recording posted in the classroom. Homework is also posted in the classroom. It's in the classwork part. And please write your answers on a piece of paper, not digitally. So in the past few years, some students have chose to do it digitally because in the classwork, if you can see, I post the homework as a Google Doc. You can just look off these problems, get a random sheet of paper, and write your answers on it, right? So please do not try to do this digitally. I don't even know if you can access it. First of all, you can view it, but you can't access it. So do not make a copy of this and do it digitally. I cannot see your work that way. Work is very important, because if you get it wrong and I don't see your work, I don't know where you went wrong. So you need to make sure you show your work, right? So yeah, that is for the homework. And also submit it as a PDF. Please do not be one of those people that submits it like as a JPEG, as a picture file. Those take like 30 seconds to load each. And if you have multiple JPEGs, let's say you have 3 JPEGs, that takes 1 minute and 30 seconds to load. Please submit it as a PDF. If you do not know how to do that, there are many photo to PDF converters online if you want to do that, right? Or if you, during that week, if you cannot find time to submit the homework, that's no problem. Just do it on your own, right? A lot of this course is discipline. You need to be accountable for yourself, because this is for you, right? You are learning for yourself, not your parents, not me, right? So you need to be accountable for yourself. You need to do the homework if you want to improve, right? So hold yourself accountable on that. And one more thing, if you're really intent on getting better quick, then you should do corrections. So when I learned calculus as an extracurricular, of course, calculus is pretty advanced, right? So you get a lot of problems wrong. You make silly mistakes. Don't just accept that. You need to make corrections. Once you make corrections, then you can really understand the material, right? And one more thing, procrastinating sometimes is good. It helps you learn more things. It helps you brainstorm more things, brainstorm deeper. But procrastination when you're doing your homework is not good. It's just math homework. Just do it. I'm pretty sure there's a study out there somewhere that says, if you review your material, one day after the lecture, you'll retain 70% of the information. But if you review your material 1 week right before this class, right? 1 week after the lecture and right before this class, you only retain like 30%. So make sure you do not procrastinate. Do it when you have time. This homework is not going to take you like 3 hours to do. At most, it's going to take you maybe half an hour. All right, if you truly do not understand and you're struggling, maybe half an hour. But if you really understood, if you're a good student, you took notes, then around 15-20 minutes, all right? Max. So whenever you find the time, please do the homework and hold yourself accountable. Okay. So now let's go on to some pre-assessment problems that some people had trouble with. Okay, so of course the first pre-assessment problems is literally just basic operations. But you're gonna need to know more than that. You're going to need to know some critical thinking, some problem solving skills. So I took some popular easy questions from some math competitions. So some of these are math competition questions. All right, for elementary school or middle school, right? So they're not incredibly hard, but they do require a little bit of thinking, right? A little bit of thinking. And none of these require algebra yet. You can literally do all of these. You can do all of these with basic operations, and that's a very, very nice part of it. You can do all of these with basic operations. So let's just start on these pre-assessment problems. So I think around half of you did not do the pre-assessment. So please take this time to try this problem out. Whenever I give you a practice problem like this, I'm gonna give you around 2 to 3 minutes, or if it's hard, maybe 2 to 3 minutes. But if it's very easy, maybe 1 minute. Okay, so I'm gonna give you a couple moments to do this problem. Look it over, right? Sometimes these problems can be solved in multiple ways, and if you solve the problem in a different way than me and you get the same answer, I would love to hear it, right? And our policy with practice problems is to put your answer in the chat. Make it private, of course. Make a private chat to me, your answers, so I can see them, and other people cannot, so they can't copy you exactly, right? So for those who did do the pre-assessment, you can just look over this problem again and give me your answer in the chat. For others that did not do a pre-assessment, please do this problem. It'll take around 2 to 3 minutes. So yeah, this is number 8 in the pre-assessment. Jeremy's train has 4 cars with different colors: red, yellow, green, and blue. How many different ways can Jerry arrange his train cars? I'll come back in 2 minutes and walk you through exactly how you would do this problem, exactly the critical thinking behind this problem, and how you do that. And just now, I see. Actually, never mind. I think there's 14 students now in the classroom. I don't know. Anyways, yeah, make sure you join the classroom. Okay. Okay, let's start. So, hopefully everybody has solved this. Okay, very good. 24, it is, yes, indeed, it is a permutation. So I don't know if anybody is very familiar with that terminology. If you do not know the terminology of permutation, don't worry. That is, you'll learn that later, I guess. But for those who are familiar with permutation, very good. Okay, so I'll explain the concept of permutation. And actually, this problem is very easy. Okay, so first, I'll explain this problem, and I want somebody to volunteer for the next problem. Okay, so this problem, I'll just very quickly walk you through it. And somebody should volunteer for the next problem, so we have a little bit of more of interactivity. All right, very nice. Okay, so Jerry's train has 4 cars of different colors, right? How many ways can you arrange his train cars? Let's say let's just give these like R, Y, G, and B, right? Okay. So what can we do to arrange these? Let's say it has to start with let's say it has to end with YG. No, let's say that it has to start with R, right? So how many ways can we arrange this with with R being there, right? So well, we see here, if R is the first car, then we can arrange the yellow, green, and blue, right? If R is the first car, we can also do G, Y, and B, right? We can also do Y, B, and G, right? So you can see how R stays the same, but we're just changing these 3 things, right? That's very important. So now I'm going to teach you something called the box method if you haven't heard of it. So let's say these are the 4 cars, right? These are the 4 cars. And well, how many options do we have for the first car? So let's just 1, 2, 3, 4, right? How many options do we have for the first car? We can choose red, we can choose yellow, green, or blue for the first car, meaning we have 4 options for the first car, right? 4 options for the first car. Well, how many options do we have for 2? We don't have 4 options anymore because one of the options was used for the first car, right? So we have 3 options. And then for 3, we have 2 options and then 1 option. You see how this makes sense? We use 1 option each time for a car, so it goes down. This is called a permutation. The key word here is arrange, because with permutations, order does matter. You're arranging all of these. What exactly is a permutation? We're not going to learn too much about statistics or probability in this class, but a permutation is n times n minus 1 times dot 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 times 2 times 1. So for example, 4 factorial here is going to be equal to 4 times 3 times 2 times 1, which is equal to 24, as you guys said. So whoever got the answer, congratulations, of 24. Very nice. Okay, so I need somebody to volunteer for this one. So who knows how to do number 9? Who did the pre-assessment and got a number 9 quite easily? Do I have any volunteers that want to speak up for number 9? You can use the raise hand feature, or you can or how about in the chat? In the chat, can everybody tell me how did you feel about number 9? Was it hard, or was it easy, or was it just right? How did everybody feel about number 9? Did you get it or not?
Do we just do number 9 right now?
Well, I'm trying to get a volunteer to try, somebody who solved it already, and try to explain your thought process. So I think Aaron, raise your hand, right? So can you unmute and
Which one's number 9? The one that we did
Yeah,
right
this
now?
one. This one, yeah. Number 9. Aaron, I think you raised your hand to volunteer. So can you tell us how did you do this problem? How did you
I
set it up?
haven't done it yet.
Oh, okay. So how about we get like 1 minute or 2 minutes? That's enough, right? 1 minute, okay. So I'll give you 1 minute. 1 minute to do this, right? And then I'll call on a volunteer, somebody who wants to do it, right? Make sure you participate, right? That's the best way to learn this. Okay, so make sure you participate. If you have not participated in a while, make sure you raise your hand or something. This is the best way to learn. Okay. So, 1 minute. Okay, so let's start on this problem. So hopefully somebody got an answer. 60%, 80%. Okay, FY is everybody. Um, Interesting. Everybody is divided on this. I don't know. Let's see what the correct answer is. So Aaron said 5/9. Ivan says 75%. We have some 60%, 80%, 50%, 75%, 20% too. Interesting. 78%. That's very interesting. I don't know. Okay, so let's actually solve it and see what we get. All right. So Aaron, I think you raised your hand earlier. So can you unmute yourself and tell us how to solve this problem?
I do not know how to solve this one.
Didn't you just give an answer? Who is the Aaron that answered 5/9 or gave like the first answer?
It
Oh,
was
there's a
me.
who's that Aaron?
It was me.
Oh, okay. So can you explain your answer? Well, actually, let me draw the picture for you first. All right. So this is one circle, two circles.
There's in total like 6 inches in diameter, and there's 3 numbers between 4 and 6.
Let me just draw the big circle first. And this is 5, 4, 3, 2. So let's pretend that these are perfect circles. Right. So what is the diameter of the biggest circle? 6, right? Okay, and that this is 5, and this is 4, and this is 3, and obviously this is 2, right? So that means that the radius is 1 for the small circle, and this radius is 1.5, this radius is 2, this radius is 2.5. So everybody has learned how to solve circles, right? So whichever Aaron that gave me the correct answer, how did you go about this problem?
I thought it was radius. And because there was in total 6 inches in like diameter, and there's 3 numbers between 4 and 6. I think it's 50%.
50%. Okay. So let us actually do this problem. So I just highlighted a little bit. I just highlighted so everybody can see the yellow part, right? I just highlighted this part. What even are we trying to find here? Between the 4 and 6 inch diameter circles, right? Well, that's between these two circles. So how would we actually find the probability that she hits the area between the 4 inch and the 6 inch diameter circles? To find the probability, well, we need to find the actual area of the shaded region. So to find the shaded region, you can see how this is the 6 inch diameter, this is the 4 inch diameter. If you subtract their areas, then you get the shaded region, right? So all we have to do is subtract the area of the 6 inch diameter circle and the 4 inch diameter circle. Well, the 6 inch diameter circle, the radius of that is 3. So that's going to be pi r squared is 9 pi, right? And now the 4 inch circle, 4 inch diameter circle, the radius of that is 2, right? Well, the area of that is pi r squared again. Pi times 2 squared is 4 pi. See, what is the area of the shaded area? Well, yeah, it is 5 pi, right? Okay. Well, we want the probability. What is the probability? Is the desired outcome over all of the outcomes. So it is 5 pi, our desired outcome, our shaded area, over all of the area, which is just 9 pi, which is 5/9. Whoever got 5/9. I saw one answer that was 5/9. Whoever got 5/9. Congratulations. Very good job. Who got 5/9? Aaron.
I did it, but I thought I did it wrong because I used the radius instead of like the actual, like I used radius instead of diameter. Well, diameter instead of radius, yeah. So I thought I got it wrong, but somehow.
Oh, well, actually, I don't think it really matters because it's just a ratio. Probability is a ratio. So even if you use 10 over 18, it's still the same thing. That's probably what happened. Well, good job nonetheless. Maybe read harder next time. Whatever. Anyways, number 10. A circle is inscribed in a square with side lengths of 10 centimeters. Since we are running a bit slow on time, I'm just gonna go over this. Right, so everybody, let's just do it with me. Okay, so I'm gonna call on somebody and you're going to just solve it on the spot, right? How you would normally solve this. So who can volunteer? Do I have any volunteers that can solve this for me?
I could try.
I could. You
Okay, who's that?
subtract the area of the circle by the wait, no, you subtract the area of the square by the area of the circle.
Right, so that was Aaron, right? So very good.
Yes.
So can you walk me through how would you start? Right, so your idea is we take the area of the square, right? And we subtract it with a circle and we get the shaded region. Right?
Yes.
Okay. So first tell me, what is the area of the square?
100.
Yeah, it's just 10 squared, right? 10 squared is equal to 100. Area of the square is 100. And that's minus what? The circle, right? So what is
Yes.
what would be the area of the circle?
The area of the circle would be 25 pi.
Yeah, very good. So this is an observation that you must make. when we are given an inscribed circle, we can find its area with the side lengths of the square. Because the side length is 10, the radius of the circle is actually 5. And pi r squared, we get the area of the circle, which is 25 pi. If you use your calculator and you calculate what is 25 pi, okay, you're going to get 78.5 something, right? And 100 minus 25 pi is going to be around 21.5, okay? A rough estimate. Okay, so even though this shaded region looks quite small, it's actually 21.5. It's pretty big. So that is how you basically find the area, the shaded area here. As you can see, this is similar to the last problem because
It is
we subtract
100
the area.
minus 78.5.
Yeah. What about
I
it?
think it's
Yeah, it
seven.
is.
It's 100 minus 78.5.
Yeah, because 25 pi is 3.14, right? 25 times 3.14 is roughly 78.5. Again, this is a rough estimate because pi is a never-ending number, so we can only estimate. So let's go on to 11. So do I have another volunteer? All right, a different volunteer this time that can try their hand at this problem. Okay, this is again the same concept. We are subtracting areas. We have gone over this 2 times before, so you should be pretty familiar with how to do this. Okay, Aaron, again. All right, so how would you do this?
So basically, so if the length of the right triangle legs is r, the area of a right triangle or like a triangle would be like r times 2 divided by 2. So this would just be r.
Are you sure about that?
Hmm.
What is the area of a triangle?
All right, yeah, r times r squared
Times
divided by
pi,
2.
right? Okay, okay.
Yeah.
So, first tell me what is the concept of this, right? By the way, this is this right triangle. So this means that this is a quarter of the circle. This is a quarter of the circle. Right, so first the concept is we have to find the quarter of the circle, then subtract it by the triangle to find the shaded area. Is that correct?
Mm.
Right, so first let's find the area of the circle, the entire circle, and the radius is r. What would that be?
It'll be r squared pi.
Very good.
Pi r squared, yeah.
And what if we find only 1/4 of the circle? We just divide that by 4, is that correct?
Yeah.
And what do we
Then
subtract that by?
r squared divided by 2.
Yes, r squared divided by 2. And now we have this. We have this. I don't know. Maybe you wanna do something with this. I mean, this is just the answer. You can try to simplify this. R squared minus 2r squared, but we really haven't gotten to factoring it, so I would just recommend just keeping it like this. And that's all you need to do. Find it in terms of r. This is, again, the same concept here. All you have to do is subtract the areas. We have done this in number 10 and in number 9. So subtracting the areas is a very good idea. Solving concept that we need to learn. All right, finally, we have A, B, C, D, and M, N, O, P are squares, blah, 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 whatever. M, N, O, P are at the middle point of the 4 sides of square A, B, C, D. Okay, see the picture below. Great. If M, N is 8 inches, number A, well, just letter A, what is the area of square ABCD? Yes, okay. And what is the area of AMP? Okay, great. So, who can solve this for me? Annie. Very good. So, a different volunteer this time. Okay. Annie, so can you unmute yourself and tell me how you would solve this problem?
Uh, So it says that MN is 8 inches. So then the area of square MNOP is 64 because 8 times 8 is 64. And we can also tell that the area of the 4 triangles is 64. So then 64 times 2 is 128.
Very good. Very good. So you used basically basic geometry here. Since both of these are squares, and the fact that the vertices of the smaller square is on the midpoints of the bigger square, you can see that these triangles are congruent, meaning that they all add up to the same square, right? Okay, that's very good. I wanted to solve it a different way that can also help us solve the number b. So let's solve it a different way. You can't I don't really want to get into too much geometry concepts. Yes, you can solve it with basic geometry congruency, but you can also use the Pythagorean theorem, right? I mean, this is what we have here. We have a triangle. Let's say this is maybe NOC. All right, so this triangle right here. Okay, well, we have already established that all these triangles are the same triangle. Okay, and we know that this is 8, right? And we know that this is a right triangle. So Annie, what would be the side length of NC and OC?
Uh, um, I'm not sure.
Well, we can use the Pythagorean theorem, right? And then we can it's quite clear. So since this is a right triangle, we know that a squared plus b squared is equal to c squared, right? Do you know that?
Yeah.
Well, let's say this is a and this is b, right? Well, are NC and OC the same?
Yeah.
Okay, so this is just, there's no b anymore. This is just a, okay? And we know that a squared plus a squared is equal to a squared, okay? And just square root that, okay? So you
Yeah.
can see how we have, let's say 2a squared is equal to a. All right, that's what we have, okay?
Yeah.
So we can separate this. We can have square root of 2 times just a is equal to 8, right? So what would a be? It just square root of 2 times something has to be equal to 8, right? Well, we just have to cancel out the square root of 2. So clearly a is equal to 4 square root of 2, because once we multiply 4 square root of 2 times square root of 2, we get 8, right? So
Yeah.
that is using the Pythagorean theorem. Is that does that seem very easy now, right? It's very easy. Once you set up this equation here with the Pythagorean theorem, it's very easy. And we know that NC is now equal to 4 square root of 2. Right, we're done here. Not necessarily, but now we can solve everything else once we know this. Well, basically, the side length of ABCD is just going to be 4 square root of 2 times 2, which is 8 square root of 2, and that's just going to be squared. We're going to get 128, as Annie said earlier, 128 here. What is the area of AMP? That's just one of the triangles, right? We can just find the area of NOC here, and it's the same thing. This is just 4 square root of 2 squared over 2, which is going to be equal to 64 over 2, which is 32. No. What is this? No. This is 32 over 2. Yes. Because 4 square root of 2 squared is going to be 16 times 2, which is 32 over 2. Is equal to 16. That's the area of AMP. And there are many ways to solve this. Many different ways to solve this. I solved this using a more algebra-based approach where we have to find the unknown variable a. You can always solve this geometrically using congruency. So that is it for the pre-assessment problems. And we're nearing the end of this class. So before we go, I just want to touch on the basic operations because the homework to this class is just going to be very easy for this first lesson. Remember, it's just basic operations, right? So, and it shocks me every year how many people get wrong the basic operations. So, please do not mess up order of operations. It should be pretty easy, right? We have what? PEMDAS. Okay, and I like to write it like this. This is for parentheses. This is for exponents. So parentheses and exponents first. Multiplication and division. Make sure that multiplication and division are on the same level. Meaning when you have 4 times 5 divided by 6 times 5, you do not do the times first and then divide it. That's not what happens. Multiplication essentially is division. Division essentially is multiplication. If you take x and you divide it by 4, it's the same as x times 1 over 4. Division is multiplication. That's why they're on the same level. That's why you have to go from left to right when you have multiplication and division on the same level. So many people mess that up. They think that multiplication is higher than division in the level of order of operations. That's completely not true because they are the same thing. Multiplication is division, division is multiplication. Same with addition. What if we get n plus 4? Well, what is n plus 4? It is n minus negative 4. Subtraction is addition. Addition is subtraction. That is why it's on the same level here. You do not do one first or out of order. It has to, when you have only addition and subtraction, you just do it straight left to right. Okay? So that is all for today. It is the order of operations. And for those who missed the start of our class, make sure that you arrive on time next time. It is 5 to 6 p.m. EST. It is 2 to 3 p.m. GMT. Just I don't know what GMT stands for actually. But GMT, it is 3 hours slower than EST. Well, basically we should go by EST because that is what the big cities go off of. EST, New York time. Okay. 5 to 6 p.m. EST. It is written in the classroom too, so do not miss the start of this class next time. Please arrive on time. I will wait a bit of time if we do not have enough students yet, but that's all for today. It is great to see you all participate in solving these, so thank you for listening, and I'll see you next time. I will post the homework very shortly. Actually, I already did post the homework, but I'll rephrase that. I'll post the recording link very shortly here. Maybe tonight or tomorrow morning when I get things all settled here. And if you have any last minute questions, please ask them now. Yes, Andrew, any questions?
Yeah, well, just quick question. Earlier you mentioned about submit the homework. So it's okay we just open the doubt and then submit from the one you post, yeah?
So yes, you go to classwork and you see the doc.
Uh-huh.
I want you to write it on paper though, because writing on paper is better for learning.
Okay, sure, I got it.
Okay, thank you very much. Any other questions? Last minute questions on on policy, on material covered today? If there are no questions, then that is all for today. Thank you very much for coming, and I'll see you in 1 week,
Okay.
January
Bye.
21st. Yes, bye.
Yeah.
Yeah. Okay. Bye.
Thank you.
Thank you.